Okay, today we're going to talk about triangle sums. A couple things when we start off with the triangle. We should know what the parts of a triangle are. So obviously we refer to corners as vertexes, plural vertices. Okay. And then we have what's called the interior angles here. Usually whenever I'm talking to you about a triangle's angles, I'm referring to any one of those three. A couple of things too. When you name a triangle, all right, we can use the triangle symbol. So it's just a triangle, and the letters of the vertices. So this example here, that would be triangle ABC. That would be okay. All right, that's a good example. Another one would be triangle BAC. Again, that's okay as well. And I could say triangle ACB, and that would work too. And if you're just wondering, you could start off with C as well, and that would be another name for this particular triangle pictured to the left. All right, so the next thing we have is a triangle sum theorem, right, up here in the corner. The interior angles of a triangle sum, or the interior angles of a triangle sum to 180 degrees. What does that mean? It means all the angles in a triangle, all the interior angles, always add up to be 180 degrees, or in other words, they're supplementary. When I take a look at this first example here, what is the measure of each angle in triangle ABC? Now, some of us might know this one right away, that it's 60, but if we were trying to actually figure it out algebraically, right, we know that angle A is equal to angle B is equal to angle C. So they're all the same angle. So at that case, I can mark it as some sort of unknown degrees. So x plus x plus x has to add up to be 180. Add the combined like terms. I get 3x equals 180. X equals 60 when I divide by 3 both sides. So the measure of angle A, the measure of angle B, and the measure of angle C are all 60 degrees. I would put this question probably around a level 1. Should be something that most of us know. Taking a look at our second example here, I've got a triangle DGO. We want to know what's the measure of angle D. Well, when I take a look at this particular problem, I already know, right, the box lets me know the measure of angle G is 90 degrees. The measure of angle O is 41. Using the triangle sum theorem again, if I add up all the angles, that should be 180 degrees. Again, the reason why is the triangle sum theorem. Right? That is the reason why I can add up all of them to equal 180 degrees. Do a little substitution. Right? I don't know what angle D is. I can let's substitute it in we'll make it our unknown x. Plus 90 plus 41 equals 180. Combine like terms, I get x plus 131 equals 180. Subtract 131 from both sides. X turns out to be 49. So, translating that, the measure of angle D equals 49 degrees. So that's actually really our answer there. The next theorem we have is the exterior angles of a triangle. Definition. What's the exterior angle? The angle formed by one side of a polygon and the extension of the adjacent side. All polygons have 2 sets of exterior angles. This is going to come back to us around chapter 6, maybe chapter 5. So you don't want to forget this fact that there are 2 separate sets. And then, as a side bonus, right, that the exterior angles always sum to 360 degrees. So that's another thing that's going to come back to us in later chapters. But let's take a look at a problem that has exterior angles here. So we'll notice the 110 here is on the outside, and this 130 degrees angle is on the outside. It's not inside. But what we can assume is that this is a straight segment, and so is this piece. So therefore, I can use the linear pair postulate and do 180 subtract 130 gets me 50. Tells me this angle here is 50 degrees. All right, take a moment, see if you can figure out what this particular angle is. Hopefully you paused it and figured it out. 70 is what you should have gotten. So now when I approach this problem, I can say, okay, what's the value of P? I can focus in on the interior angles of the triangle. So I can take away these pieces and just focus on the actual inside of the triangle. I can see that it's going to be 70 plus 50 plus whatever P is will be 180. And again, the reason for that is triangle sum theorem. Right? I have a triangle, I have 2 of its 3 interior angles, I can use that to solve that. Now we just resort back to some algebra, 120 plus that P angle, and then subtract 120 from both sides, gets me P to be, that's not right, silly, yep. P turns out to be 60 degrees. I put this at probably a level 2. Let's take a look at this next one. So same type of picture. It has exterior angles extending out. They give us 2 exterior angle measures, the 123 and the 92. So immediately I can figure out what angle 1 is, right? Angle 1, the measure of angle 1 is going to equal 180 subtract 92. Again, the reason for that is because 92 and this angle 1 are a linear pair. So the linear pair postulate says they should add up to 180. So that results in 88. Next, the same logic applies for angle 2. Let's see if you can figure out. I'd pause it right here if you can and figure it out yourself. All right, so you should have gotten 57. Angle 3 requires a little bit more work. Again, we're going to focus for angle 3. Since I don't know the exterior angle, I'm going to focus in on this triangle. Since we've already figured out angles 1 and 2, to figure out angle 3 here, I know that the measure of angle 3 plus the measure of angle 1 plus the measure of angle 2 has to equal, or has to add up to be 180 degrees. So now, since I already know the first 2 results, 88, well, put them in the right spots. So angle 1 is 88 plus 57 equals 180. Little side work here. 88 plus 57 is 15, carry the 1, gets me 145. So the measure of angle 3 plus 145 equals 180. Subtract 145 from both sides. The measure of angle 3 turns out to be 35 degrees. To get measure 4, again, I use that linear pair postulate again. So I can figure out that this is really just 180 minus 35 because, again, they're a linear pair, angle 3 and angle 4. So that gets me 145 degrees. Couple new parts. We have remote interior angles, so 2 angles in a triangle that are not adjacent to the indicated exterior angle. So this is another angle relationship. This one's particular to triangles. especially when you have an extended side. So angle A and angle B are remote interior angles to angle, and we're going to focus on this exterior angle. So I'm not going to say C, I got to use 3 letters here. Angle DCA, right? So this exterior angle has some remote interior pairs here, and that would be this angle here and this one here. I'm going to mark them different because they're not always congruent. Sometimes they are, sometimes they aren't. Which then leads us to the exterior angle theorem. So this one you're going to use a lot for whenever you're solving for missing measures of a triangle. And this one says the sum of the remote interior angles is equal to the non-adjacent exterior angle. So using the same picture as before, what the theorem is saying is that the measure of angle DCA equals the sum of the interior angles. So in fact, if I add these two angles, that sum results in this exterior angle. How do I use that? All right, so when I take a look at this picture, again, I got a triangle with an extended side here. This is my exterior angle. So we know then the measure of STC should be the sum of its two remote interior angles. So in this case, it would be the measure of angle C plus the measure of angle A. So do my substitution, 121 equals, right, I don't know what the measure of angle C is, plus 16. Subtract 16 on both sides. That's going to result in, I'll show my thinking here, 105. So 105 equals the measure of angle C. I'd put this example probably around a level 2. Let's take a look at a little bit more complex of a level 2. All right, same logic applies here. All right, I have an exterior angle and two remote interior angles to it. So if I add, right, if I take that exterior angle, it should equal the sum of the two remote interiors. So 4x plus 2 plus 2x subtract 9. Right? So I can set this up, right? Exterior angle theorem allows me to do this setup. Combine like terms. 5x plus 13 equals 6x subtract 7. I'm going to subtract a 5x from both sides. And I'll show my thinking on this particular problem. Make sure that we are all on the same page. And then add 7 to both sides. 20 equals x. Now that doesn't say that the angle is 20, simply that the x value is 20. If I wanted to figure out what those measures were, I would actually plug the 20s back in, or 20 back in for x. All right, and that will complete our lesson for today.